So chapter 13 and 14 are on various parts of trigonometry. And the introduction to trig is basically just looking at periodic functions. So technically a periodic function is a function that repeats a pattern of y values at regular intervals. So you can look across and you would see repeated y values over and over and over again, and they would be at the same distance apart. So for today, what I want you to be able to do is to look at a function, determine whether or not it is periodic. Is it repeating itself over and over and over and over again? The same y values reoccurring over and over and over again. So determining if it is, now these two are, we're going to identify the cycle in two different ways, which means, and I did put colored pencils up there if you want to use different colors to identify the cycle in two different ways, or we're just going to darken parts of the graph in a couple of different ways. And we are going to determine what is the horizontal length of each cycle. So if you look at the function, pick a starting point. Doesn't matter what you pick. Okay, I'm going to pick way on the left-hand side of the graph so we can do it twice. But like way down here, it starts at -2, right? So one cycle, I'm going to trace the graph until I get back to -2. That would be one cycle. Another way to identify would be to pick another starting point. We could pick like 0, 0, and trace the graph until we get back to y equals 0. So when we're identifying the period of the graph, we're figuring out what's the length, the horizontal length, from where we started to where we ended. So 1, 2, 3, 4. And if I check my other one, going from here to here, again, I'm going from 0 to 4. So part of it is to identify the cycle, which if I did in two different colors, then you can do it two different colors. And what's the period of the function? So how long on the x-axis does it take for that function to start repeating? And in this case, it is 4 units. If we look at B, there are numerous ways that you can do this. You could start from the bottom and come back to the bottom. You could start at where it hits 0. Oops. So our graph goes down, up, down, up. So down, up, this would be our new starting point for the next cycle. Or you could start at the top and just go down, up. So depending on where you start, it might be easier for you to see where it's going to start repeating if you pick like a high point or a low point than it is to pick a middle point. But it's up to you which of those you choose. And what is our period? So if we started at this low point and came back to this low point, that's a distance of 3 units. This one's hard to read, to go from here to here, right? So that's probably not the best points to pick because I don't really know exactly what this value right here is. So, but if I go from top to top, 1, 2, and they should be the same in both cases. So our period, the length of one cycle along the x-axis is 3 units. In the second example, we're not necessarily given periodic data or a periodic function. we're going to determine if it's a periodic function or not. And if it is, we are going to determine what the length of each cycle is, what the period is. Okay. So if you look at the graph in A, we have a nice squiggly line that seems to basically just squiggle in the same pattern over and over and over again. Is it periodic? The answer to this one is no. And the reason is we're starting at 3 right here. Okay? Which means if it was periodic, we would eventually have another loop that would come up over 3 again and again and again. So this is a nice squiggle that looks uniform, but the y values are not repeating. If it was repeating, it would keep coming back to that same height over and over and over again. This one does not. So this one is not periodic. If we look at B, we start at 2 here, then 0, then -2, then we do a squiggle, back to 0, back to 2. So 2, 0, -2, 0. 2, 0, -2, 0. So the y values repeat. We started here, we came back to here. We dropped down to here, we dropped down to here. We go through 0 at the same interval. So one cycle of this graph would be like that. Start at the top, go down, do some squiggles, come back to the top, then it's going to go down, do some squiggles, come back to the top. And the length of this cycle, we go from 0 to what? 10, right, on the graph? So this one is periodic, and the period is 10. And this third graph is actually just a repeat of the B graph. They just put in some points for us to look at. Okay.